Hi, everyone. One of my flatmates is just singing upstairs. Yes, it sounds kind of nice. Um, okay, welcome to this workshop. My name is Yatka, and the workshop is called Grand Gesture Storytelling with AI. And I'm working on a programming language that is called Snap. And I don't know who of you has been in the previous workshop. If you've been in the previous workshop, sorry, you'll have to listen to my Snap intro again. But I'm working on this program. Welcome. I'm glad that you joined from all over the world. Like the previous workshop was really cool. Like people are staying up forever long for this. So this is super cool. I'm sitting in Germany right now, so it is kind of late here too, 9 p.m. And as I mentioned in the previous workshop, I'm working on this programming language that is called Snap, and you can access it in the web browser. You can access it too if you're interested in doing any of this later at home or forcing your teachers to do it in school if you're still in school. Um, and the idea of Snap is that you program by dragging and dropping together these blocks. So you can see all the blocks on the left-hand side. This area we call the palette. And in the palette, we have different categories. And yeah, genau. I have the chat open. Um, and if you have any questions, just type them in the chat. I can see your questions and I'm trying to answer them while we're doing this. And it's no problem if you don't feel confident in programming, we'll really go through this step by step, and I'll share my project at all steps. So you'll, even if you don't manage to do it, you can just keep working in my project. Let me actually do this right away. Save as. I'll save this as Grand Gestures JOTA. And then I can share this project with you. So this is the project we'll be working in. And whenever you open that link, you should be able to see my current version of the project. But getting back to Snap, so you program by dragging and dropping blocks together. You have the blocks on the left-hand side here, and you have the central area, which we call the scripting area. And in that scripting area, we have you can stack blocks together to larger scripts. So for example, let's say I wanted to make my object turn around and say something. I could just turn it 15 degrees and then I could tell it to think or say hello for 2 seconds. So whenever I do this, let's say 1 second, and I click on this to execute this code, then it'll turn a slight bit and say hello for a second. And you can execute code by either clicking on it or you can attach what we call hat blocks. So for example, I could also attach the when space key thing is at the top. So whenever I press space now, I'm pressing the key, it's doing these things. So this is how you program, and you program these objects. We call them sprites, and you can see what they do on this area on the right here that we call the stage. What I want to do with you today is in the area of, okay, now let me actually close my 500 windows, is in the area of machine learning. And where, if, I don't know what you know about machine learning, but AI is currently, like, everybody's talking about it. And there's different types of AI. Usually you see this like, it's not really Venn diagrams. It's these diagrams where like things are inside of each other, and the general term is artificial intelligence, and everybody's talking about artificial intelligence right now. And one part of artificial intelligence is called machine learning. So this is one part where machines actually learn from data that you give them. And there's different types of machine learning, like three big parts. One of them is called supervised learning, and that's where we're working in today. Just so you know, the other ones, and a typical example of supervised learning would be I have a lot of images of a cat and I have a lot of images of dogs, and I know which image is which. So this is the labeled data that I'm working with, and we'll come back to that graphic. So you always have labeled data. In this case, we'd have pictures and we'd have what's on the picture as a label. And then we'll feed these pictures into our machine learning algorithm. And then that algorithm finds a pattern. And sometimes we kind of tell them how to do it. Sometimes we don't really know how it does that. And it tries to find this pattern to match input and label. And we do that with not all of the data we have, but we keep some to test it. So let's say we take 80% of our pictures, we mix them, cats and dogs, we take 80% of the pictures we have, we feed them into the algorithm, and we keep the last 20% to check whether it's correct. And then once we check that and it worked, if it doesn't work, you have to mix again and try to do it again, find a new pattern or different patterns. If it works, you can then take new data and label that with the same machine learning algorithm that you just trained. So this is the first one. The second one is called unsupervised learning, and it's used for different purposes. So for unsupervised learning, you have unlabeled data. This could be something like user data on a shopping website. So you don't really have this is that kind of shopper, but you rather have what are people buying and which people are buying which things, and you can find clusters in that in that data. So here, instead of having labeled data that we can actually look at, we just have some data points and we're trying to find similarities or patterns in these data points, and then we're trying to find clusters in there. So for example, that could be something like identifying people that always buy a lot of stuff when it's on sale versus people that don't care about this at all and they don't wait for sale but they want all the new things right away. And then you can, for example, do specific marketing to specific clusters that you find in your data, and you use that using unsupervised learning. And the last one is called reinforcement learning. Reinforcement learning is a pretty cool one too. We could have done that too, but I decided um, on the supervised learning thing. So the idea of reinforcement learning is pretty close to how we as humans learn. So the first step here, this is a four-step thing. The first step is you capture a state, and here you don't really have any data or information, and it's often used to, for example, train robot arms in companies in like manufacturing factories, to get the right position to do things correctly, or to find the right settings for I don't know, climate, like how do you call the heatings in your house, for example, finding the right settings for heatings in large houses or something like that. Or a lot of games are trained with reinforcement learning too. Like if you have AI assistants for games, those are often trained with reinforcement learning, chess computers, or the Go AlphaGo thing that beat the Go world champion a couple of years ago, that use reinforcement learning. And the idea here is first we find a state. So in chess, that would, for example, be the current position of the board. Then for that position, we'll just try an action. If we don't know anything, we'll just try one randomly, and then afterwards, we look what happened. If that was a good action, we receive a reward. If that action, for example, in chess made us lose or lose a piece in the next step, then we receive a punishment. Usually, when you work with computers, punishment means a negative number and reward means a positive number, but yeah. And then afterwards, you incorporate what you just did, like the state, the action that you tried, and then whether it was good or not, into the adjustment of the strategy. And when you come into that same state the next time, you'll more likely use the action that was positive the last time, and less likely the action that was negative the last time. And so, kind of by trial and error, you'll find out which things are good. And also, if you think about it, this is pretty close to how we as humans, for example, learn, how we as humans learn to, for example, not touch a hot plate on the oven or something. We're having a state that we're trying something, we're touching it, it was hot, we receive a punishment like pain, and the next time we'll adjust our strategy. So this is kind of, yeah, mimicking how humans learn. Okay, circling back to the supervised learning, we want to work with labeled data. We try to find patterns in the data to match a label with the data, and then we try to label new data. How do we want to do that in the grand gestures thing? Here we first want to start by creating a drawing program. Let me actually open an example how this could look like in the end. Grand gestures, no white. So here, for example, I made a version that I can use to tell the story of Snow White, not the whole one, I only did the beginning. A long, long time ago, there used to be a princess, and she was often sitting. Oh, sorry, this is the princess. This is your crown. She was, come on. How does the crown work? I should have practiced this before. Anyway, she was sitting at the window and looking outside of the window. And whenever she often sat there and was just looking out of the window, and while she did that, she was like doing needlework. She was also freshly in love because she just got married to the king, so her heart beat a lot. Once, while she looked out of the window and she newly found out that she was pregnant, it suddenly started snowing a lot. So she was looking out of the window with her needle, snowing a lot, and suddenly she stung herself with the needle. Oh. And while she did that, a small droplet of blood fell down on the white snow on the windowsill. And suddenly she came up with a very good name for her unborn child, and she wanted to name her Snow White. So as you can see, what I did here right now is, oh, I forgot the stars. I can draw gestures here. And it's actually using the gestures that I'm drawing. It's identifying the gestures, it's recognizing the things. So here it's recognizing that I drew a star. If I'm drawing the heart, it's recognizing that I'm drawing a heart. For some reason, it doesn't recognize the crown. Anyway, and we can create our own drawing program, and we can use that to train our algorithm with our own examples, and we can animate these examples. So with our actual drawings, like with the snowflakes, we can create. Hey, come on, this is a snowflake. Oh, now it thinks it's a crown. Okay, interesting. Um, so with the our own, no, this is a snow. With our own drawings, we can animate and animate our stories and tell them nicely with our animated gestures. Okay. We can do that step by step by working in the project that I am sending you right now. Let me open the chat. And no, you're not meant to do anything right now. You're please opening the project now, and now you're meant to do stuff. um, the first thing we have to do for our project doesn't have to do with AI a lot yet. It has to do with creating a drawing program, and that drawing program is supposed to do single stroke gestures. So our thing only works with single stroke gestures, meaning once you put the pen down, you can draw everything that you can draw in one line, and once you release the pen, it'll stop drawing and the gesture's done. um, good. The next step, so the first step that we have to do for this is so we want to trigger our drawing program, and I could have actually added that because that's not computationally very interesting. The first step is we need to trigger the drawing from the stage. So what I want you to do first is select the stage object and then add the when I'm clicked blocks and broadcast blocks. Because what this is supposed to do is whenever we pressing the stage, we want to send a message to the other object that's actually doing the work. This is just to trigger that the drawing process starts now. So I should have added that for you. But anyway, and we don't want to start when I'm clicked, because clicking means that you put the pen down and then you release the pen again and then it triggers. What we want is when I'm pressed. So we get the trigger already when the pen is down. So the first thing you do is from the drop-down menu, you select the when I'm pressed option. Sorry. Again, I said in the workshop before too, I'm unfortunately a bit sick, so occasionally I have to cough or clean my nose. So I'll be back in 2 seconds. Okay, so now we need to send the message. So the trigger works, but we need to tell what we want to trigger. So we attach the broadcast block here. Now we need to select the message we want to broadcast. And we do this by clicking on this drop-down menu here. And then you have several options. One is an empty one, then you have the green flag, and then you have new. And I want you to click on new so you can type in a message. And this, in this case, I want my message to be maybe sketch, because I want to start the sketching with that trigger. So I'll give you 1 minute to build this because you need this, and then we'll work in the other sprite. So the blocks that you need is the when I am clicked, but you need the pressed option, and then the broadcast block. And then in the drop-down menu, you click on new, type in sketch, click OK, and then you're good. Okay, we'll wait for 30 more seconds, so we'll make sure that everybody who wants to tag along has that. Okay, and then if you have that, I'll update. If you're not entirely sure, you can start from my link now again. And we go back to that sprite that's supposed to do the actual drawing. And in that sprite, we'll now program a drawing program that reacts to the sketch trigger that we sent. So we can start by grabbing one of the when I receive blocks, because that one can receive the message and then do stuff. So when I receive the sketch message, I want to do something. The thing I want to do is I want to go to the mouse pointer, and I want to do that as long as the mouse is down. So as long as means repeat until, and we're repeating until the mouse is not down anymore. By the way, what I mentioned in the other workshop, I didn't right now, there's this is kind of hard if you don't really know any programming, but you can distinguish, or you can figure out where the blocks are by looking at the color. So if I'm grabbing a yellow block, you have to go to the control category because that's the yellow one. To grab the repeat until, for example, if you see that I grabbed the not block, that's a green one, that's from the operators category. Still, we have tons of blocks. So sometimes I'm doing this quite fast because I do this a lot and I know where all the blocks are. So if you can't find the block that I'm mentioning or can't see it right away because they're overwhelming and there are so many, you can use the block search. In each category, at the beginning on the top right corner here, you have this magnifying glasses, and when you hover over them, you get the mouse over find blocks. If you click on this, you get a search window, like a search bar. And for example, let's say you didn't find the repeat until block, you can just type repeat and then until in here, and then you only have one block left. Or just repeat, then you get the two blocks that are named repeat. And this also works for mouse. We have more blocks that contain the word mouse, and you can just look for them and then find the corresponding one that you need, here in this case, this one. And if you want to get rid of the block search again, you can just click on any category and you'll just get back to the regular palette. Okay. So the thing we wanted to do until the mouse isn't down anymore is go to the mouse pointer. So in this case, we'll grab the go to block. This one has random position by default selected in the drop-down menu, so we need to change this too. And we want to go to the mouse pointer. So if we do it like that, I can click here, then the object moves to the mouse pointer, and then it follows my mouse pointer until I release it. And now I've stopped having the mouse down, and now I can move the object freely without this object following it. Again, if I click here, it moves to my mouse pointer and it's following around. This is nice, but it's not a drawing program because I'm not drawing. So what we should add too is pen blocks, pen down and pen up. If we're adding the pen down block right at the beginning here, don't do it. Um, I'll just show you. If we're adding the pen block right at the beginning here and I click here, you see that it's also drawing the way to the new position. So don't want that. What we want instead is putting the pen down after we went to the mouse pointer. Oh, wait, I forgot to put the pen up again. After we went to the mouse pointer for the first time. And then once we're done, we put the pen up again. So now when I draw something, I'm moving to the mouse pointer and then I start drawing. And once I release, I can move to a new position and draw there. As I told you, though, this is supposed to be a uni-stroke gesture thing, single stroke gesture thing. So now I drew a lot of gestures or a lot of sketches on top of each other. What I want to do instead is I want to clear every time before I start a new sketch. So now I can draw a heart, or I can draw a clef, or I can draw a star, or I can draw, I don't know, boat. Some things are quite hard as uni-stroke gestures. Some things work super well. So you can build the drawing program and try to find a couple of things that you can do as uni-stroke things. Okay, I'll give you 1 minute to build this thing. Hello. For people who are coming late, where I'll save this. We're currently working on a single stroke drawing program, and I don't know whether you can see the chat when you're new. So this is the project that we're working in. If you open this now, you should have my current version of the project. Okay, someone said that their stage went black before using the sorry, now I'll close the Q&A before using the pen. Okay, interesting. You can, there's a way to make the stage black. For example, if you use the background, so set the background color, so maybe that happened. Other than that, I don't know. Maybe you just open my project again because I can't see your project, so it's really hard to debug. Maybe just open my project and keep working in there, and then you can try to figure out what's not working in yours later. Okay, so I now ask you to all do one draw, or maybe no, let's one more thing. I think this is a very thin pen size, so I think I want the pen size a bit thicker. You don't have to include that into the sketching program. You can just set it to 3 or something, then it draws with a thicker line and you can see it better. If you want to, you can also include it in here. That works too. Okay. Oh, great. Now one of my other flatmates found out about the piano. Very musical group here tonight. Good. So now I have this one drawing, and what I said before is before we start with the actual training and AI and recognizing blah part, we want to have a drawing program and we want to animate our drawings. So this is purely computer science programming. And in the looks category, you can find a block that lets you animate something. No need for you to do it, I'll just explain it quickly. The animate block uses this one idea of the pen trails. And the pen trails, I'll just duplicate this, is a reporter that lets you, what it reports a picture of what's currently drawn on the stage. And in this case, this is my heart. If I draw something else, now I get the star. So this is just a picture of whatever I've drawn on the stage. And in that animate block, we'll use this as a costume for the object. So if I switch to the costume pen trails, I'm now this star. So this is my drawing, and this is the object that now looks like a star. And the animate block does that for you by itself. So if you look at it, this is just housekeeping. It sets the object to the center. It points the object to the right direction. It sets the size to 100. Then it switches to the costume. And then it says run whatever's in here while you're wearing that costume. And then once you're done, just put everything back and stamp the drawing again on the stage so it looks like it did before you started the animation. So for example, if I animate my heart, and I used the heartbeat as an example in the previous workshop, so we'll just use it again here. If I want to animate my heart, what I wanted to do is I wanted to slowly increase in size and then quickly reduce the size again to 100%. And I can just do this inside the animate block. So first we want to increase the size slowly by repeating change size by 10 times. If I do it like this, I'm getting it done once and then it's automatically resizing, but I maybe want to do it twice and resetting it to 100 again. So I wrap another repeat around it and I'll reset it to 100 before I increase the size again. So if I click on this now, I'm getting a heartbeat twice whenever I click on this. So this is my heart. Now, if I want to have what else could I do? Let's say star. I had the star in the other project. If I want to draw a star, I don't want this to happen. I want something else to happen. So for the star, for example, I wanted to flicker and turn a bit. So I wanted to show height, show height, show height, and every time in between, it's supposed to turn, let's say 36 degrees, and then it's supposed to do it 10 times, so it'll cover a whole circle. So I can grab another one of the animate blocks. And this time I want to, as I just said, I want to repeat 10 times that it's supposed to turn 36 degrees. If I do it like this, it'll just doing it super fast. So maybe let's turn 18 degrees and then show, and then turn 18 degrees and then hide. And if I do it like this, it's still super fast. So maybe we'll also need to wait a tiny bit in the middle. So we do this, wait 0.1 seconds. And then we do this and wait 0. So now I get this star and it's flickering and moving in a circle. You can come up with your own things. It's fine. So now I'd give everybody 5 minutes to come up with their own animations. You can use different blocks. You can also let it say things. You can let it move places using the move block. So there's different things that you can come up with, and everybody now has 5 minutes to do that. Okay. I'm unfortunately not very good at drawing, but this seems to work. So now I added 4 things, and I hope you managed to do a couple of them too. So as I just showed, I've got the heart, and if I click on this, it can beat. I've got the star that can flicker. I made this clef thing, and I actually also wanted to play sounds with it, but I didn't manage to do it yet. So this can just move around. But I could, for example, record something and I could start playing it before I do this and then hopefully be done while we can add this later. And then I made a propeller, and all my propellers look kind of weird, but this propeller can rotate. And I use the for loop to do this. Why? Because it's automatically decreasing. So it starts with the for loop has this internal variable that's called I, and the first time the block is run, I is set to this first value, and then it's automatically, in this case, decreased until it reaches this last value. So I'm starting with a big angle, like a large turning angle of 150 divided by 530 degrees, and then it's increasingly getting slower because this I value is automatically decreasing. So I start with a very large rotation, and then the propeller is increasingly getting slower. So stuff like that is what you can do too. Okay. I hope everybody managed to do at least one animation. And now we kind of wanted to automatically recognize them. And we need several steps to do that. So the first one is we need a way to even compare our gestures. And one easy way, one way to do it is just to compare the paths we've drawn. So whenever we start a new sketch, we have to track the paths, the coordinates that we're moving, and we can do that by creating a variable. So to do that, go to the variables category and click on the make a variable button. This is right the first button in the orange category. And if you click on it, it opens this window and you can type a name in here. And I want to name my variable sketch. Now I'm naming it path. Path is good. I'm naming it path. And then I click on OK. What I'm getting now is a delete button if I wanted to delete it again. But I'm getting this orange blob here. And this orange blob saves the values, like, and I can click on this, and right now my path variable is 0. So if I click on this, I'm getting the value 0. But if we add our path, we'll get the coordinates. And what I'm also getting is the option to select this path variable in the drop-down menu of the set block. So please all do that. Click on the make a variable button, make a path variable, and then drag these 2 things out. As I said, we want to make a path of coordinates that we're drawing. That means we're going to a new position to the mouse pointer, and then right afterwards, we're adding that position to the path that we're collecting here, that we're saving here. Also in the variables category, but farther down where the red list blocks are, you find the add thing to block. This has 2 input slots. The first one is what you want to add, and in this case we want to add the position our object is at, and where we want to add it to is to the path variable we just created. So I'm adding the position to the path whenever I went to the mouse pointer. So I'm first going to the mouse pointer, and then I'm adding the position to my path. If I do it like this, look at what I'm doing, careful, I'm getting an error message. The error message was, I'll click on it again, it says, I'm expecting a list, but I'm getting a number. We're adding something to a list here, but right now, our path variable is 0, which is a number. So this is a kind of type problem. So we need to make sure that this is actually a list before we can add things. And to solve that problem, you can grab this red list block and set the path to an empty list. So you grab the list block, you click on the left arrow once, so you only have this red blob without the input slot, and then you put it in here. And we want to reset the path anyway every time we start a new sketch. So when I'm starting the sketch, I'm drawing the path. And now you see that in this case, for example, I got these 212 points. I started at the coordinate minus 170. The first one are the x coordinates. The second one, like the second column, is the y coordinates. And then I ended at 19 minus 73. And this is the coordinates of my heart. If you draw something else and start up here, for example, you see now it started at 161.96. So this is just the coordinates on the stage. The center of the stage is the origin of the coordinate system. So that's 0, 0. And then on the left, we have negative values. On the right, we have positive values. Same is true for top and bottom for the y coordinate. Okay. Okay, someone is asking whether it's possible to change the rotation type with code. Okay, this is a pretty advanced question, but good question. Build your path thing, and while you do that, I'll explain. For example, when I do the clef thing, and I'll just do this a lot of times so you can actually see what's happening. Whenever it's moving backwards, it's kind of turning around. So by default, objects have the can rotate in any direction thing. If I only wanted the clef to move left and right and never turn around, so I always wanted to face in the same direction, I can change the rotation type. I can do this manually. So now I could say I always wanted to face left and right, but the problem is if I do this, if I do it like this, I it's now happening like for the flickering star too. So now I can't turn the star either because I decided that the rotation type is this one. So is there a programmatic way to do this? Yes, it's kind of hidden, but it's in the set block too. So in the settings, you can set my and then my attributes of an object. This is really just for the people who are interested. No need to do this. And you can set my rotation style too. And then we'd have to check what the current, I don't know which one's which, to be honest, but you can find it out with the my block. So my rotation style right now, when I'm in the can rotate, is 1. If I set it to only left and right, it's 2. And if I set it to can't rotate, it's 0. So if you, for example, wanted to do the can't rotate, you can animate this, put the animate block on it, and then set the rotation style to 0 in there. And this should work. Let me just try it, actually. I'm drawing a new clef. And then I'm switching to this. And now I set the rotation style to this. And then, for example, if you wanted to set it back to something else, you could either do it like right up here. Whenever you draw something, you set the rotation style back, or you could do it in the other object where you want a different rotation style. Okay, I hope that answers the question. Good. Ah, yeah, and then there's someone new in here. So I'll save my project again. Um, Glad that you joined. We're working in my version of this project. Like everybody builds their own, but you can start working with this one. And what we did so far is create a drawing program. So we made the sketching program, we wrote this. And what the sketching program does is whenever you click on the stage, when you press the mouse on the stage, it starts drawing, and then you can draw a unistroke gesture, meaning once you're done drawing and start a new one, it'll delete the old one and draw a new one. So this is what that does. And then we wrote scripts that can animate our drawings with the animate block. So everything you put in here does an animation of your drawing. It switches to, like, the object switches to the costume that of your drawing, and then does whatever's inside the animate block, and then switches back so you can draw again with the regular thing. So this is what we've done so far. And we created the path variable. So we're now logging the path that we're drawing, the coordinates of each object, of each drawing, so we can follow along and then start comparing sketches. Okay. The next step we need to do is I leave this path variable open and I'll draw a heart now. I'll draw this heart. And I have the coordinates for it, and it's 441. Now I draw another heart. And this other heart only has 63 coordinates. So the problem is if we want to compare them, we're kind of doing it step by step. We need to what we call normalize the drawing. So we need to make sure that they all have a similar amount of coordinates. So what we need to do before we can start actually generating our training examples and then comparing differences between paths is that we need to normalize the paths to a specific number of points. And we already prepared blocks that help you do that. You can find one of them in the pen category, and it's called render. So this is the render block. And with the render block, you can render your paths. So if you put your path in there, you see that usually also the points aren't evenly distributed across a path. So at the end and at the beginning and wherever you change directions, you're usually drawing slower than where you draw straight lines. So you have less points on the straight lines, you have a lot of points here in the middle. So we want to evenly distribute the points across the path and have the same number of points in all the paths. And we already prepared a block for you that does that. And this block is called resample. And in the resample block, you can put in a path and then you can tell the block to resample that path to a specific number of points. By default, it's 64. That's also a very good number. Like it works well. 64 is an equally good number as anyone, but it works well for the project. And what you can see here is that I'm now getting all these like intermediate decimal numbers, and it just calculated, made the distance between each point equal. And you can also see that when you, instead of render the original path, you render this resampled path, like this is the original one, this is the resampled version, you see that the points are now evenly spaced and we only have 64 left instead of the whatever I had here. Okay. For you to do now, maybe 2 or 3 minutes, try different shapes, see how they are rendered if you render your path, and then try rendering them with a specific number of points. And maybe also try to see what's the minimum amount of points you can use to still kind of distinguish it as a human. Or here, for example, with the star, 8 doesn't really work anymore. 10, nah. 12, nah. 12 I'd say is kind of okay. So the more complicated a structure is, the more points you need. Like when you think about a square, for example, for a square, 12 points are kind of okay. So you can see that this is the shape. If you do something more complicated, you probably need more points. So try a couple of things and just see how the points are distributed and how they look if you render them differently. Okay, 2 minutes. Mm. Mhm. Okay. Now that we know all about the rendering or about the resampling, we can actually start creating training examples for our animations. To do that, we can create another variable and we call that variable examples. In my example, and again, examples needs to be a list first because we want to add things. So next step, we'll set the examples variable to an empty list. But we can throw this away now because we don't probably want to reset it again. So now that it's an empty list, I can throw this away again. And now I can write the script with which I can add examples. So I'm adding examples to the examples variable. And what I'm adding is, you remember we want to do supervised stuff. So we need a label and we need the data. So the data in this case is supposed to be the resampled path and the data is the resampled path and the label is the word that of the thing that the gesture is representing. So in case of a heart, for example, if I draw my heart now, I'm having the resampled path and then I have the word heart. So we'll grab another list block and create how we want to label the data. The second item in that list is the word of the thing that you've drawn. In this case, I start with heart first. And the other one is the resampled path. And as I said, you can pick another number, a different number. 64 points has proven to be enough and works quite well. And I'd suggest we just stick with the 64 that are there as a default input. So the first entry in the list is going to be our path, and the second one is like the resampled path, and the second one is going to be the label for that gesture. And then you drag that in here where it says thing, and then your job is for the next 2-3 minutes to draw something, a heart, for example, and then click on this. And what you get here is this kind of weirdly looking entry. The first one is the path, the second one is the heart. If you want to look at this differently, you can right click the inner part of the list and then select the table view. Then you just get it as the table. So the first one is a list, this is the path, and the second one is the word. So again, you right click where it says one, and then you can switch between list view and the table view. And I think the table view is the better one for this. And also make sure that you draw several examples for the heart because there's different hearts. So I can this one, and I could have this one, and they are all hearts. So now I have 3 hearts, and then preferably draw whatever your animations are for, so you know you all have all of them. So I also had the clef. And let me add another cliff. And you can do this for your examples while I'm doing this. And another cliff. And then I add star. So I'm drawing stars. Okay. And then I did have propel. Okay. So I've got my 12 examples now. I drew 3 of each of them. We can talk about this later, whether more examples are better or not. But for now, please all create your examples. And yes, you're in the Grand Gestures event. Welcome. I'll save my project again and post it to the chat again. If you want to join, you can start working in my project, although I'll recommend adding your own examples to the examples list because I trained it with my examples now, and you might draw yours differently. I'll show what I mean by that in a second, or probably in 10 minutes because we'll do the other stuff first. Okay. So the next thing we can do, now we have a list of examples. Okay. Are you getting someone still getting the expecting list but getting number message? I assume you're getting it for the sketch. So the important thing is that every time you start a new sketch, you set the path to an empty list again. Because every time after you go to the mouse pointer, you want to add something to a list. So you need to make sure that the path actually is a list. So at the beginning, set the path to an empty list. And the way I did that was I grabbed the set block, I picked the path variable, and I have to like remove the one input slot from the list. So this is an empty list now. When you click on it, it's a list with length 0. And then every time you draw something new, you set the path to an empty list. You can also check that whether it works when you see the path variable on the stage and you start drawing, or you click here, it should be an empty list. And then when you start drawing, it should be filled up. If yours says 0 for the path, it's still a number. And to make sure that I always have that, I just attached it right at the beginning of the sketching process. Add resample. Okay, okay. We're not adding just the resample. Yeah, for the examples, I did the same thing too. I just deleted it again, but let me just put it here. So for the examples, you have to do the first thing, the same thing too. I don't want to click on it because I don't want to reset my examples now. But you once at the beginning, you need to set the examples to something that is a list, that looks like this. And once you have that, then you can start adding stuff to the list. And again, here it's important that what you're adding is a word as a second thing and the resampled path as a first thing. So you want to add a list, resample path, plus the tag, plus the label for that example. Okay, maybe I'll just rearrange my things here, then I can leave all of them. Okay, perfect. Works now. Great. Okay, then we'll give Daniel a bit of time to make his examples. And everybody else can add more examples. More examples are never bad. So we can add another propeller maybe, or I'll add another star. Good. By the way, because I've seen that a couple of people are asking for recordings. Again, I don't know how the recordings work, but we do have a very lengthy professional development session for teachers about this, with even a talk from a professor in the middle. If you give me 2 minutes after we're done with the next step, I can fetch it from YouTube and post it here. So if you want to follow along again, you can do that later. Okay, good. So now the next step, we have examples, we have a path. How do we get both of them together? How do we find out what we probably drew? In the sensing category, you can find a couple of blocks that we again already prepared for you. One of them is the difference between shape and shape and huh. So these two input slots both take a shape, and one of them is our path, and one of them could be a path from the examples. Don't do this, just watch, because we already have the recognized thing done. I just want to explain what's happening here. So in this difference between shape and shape block, you can see that this is a pretty simple algorithm. We're just measuring the distance from each point in the first shape to each point in the second shape. And this is why it's important that they have the same amount of points, because otherwise they don't map and everything will be wrong. And then we're adding these distances up. So this is just each coordinate is compared to each coordinate, and the distances are added up for all 64 points that we have. And then we assume that shapes where the difference is smaller are more similar to each other than shapes where the distance is larger. By the way, I haven't mentioned that the algorithm that we're using here is actually it's called the $1 gesture recognizer. $1 because it's so cheap. But it's a prototyping algorithm or prototyping program that was invented by the University in Washington, and they use it for gesture control in apps or something. And why it's not actually productively used, it's really a prototyping algorithm because it works super well with very little examples. And that's why it's pretty fast and yeah, pretty simple also to build. Most gesture recognizers are more complicated and even use neural networks and blah. So this one is a very simple one, but it works pretty well. And they also have a couple of more mathy things in there. Like we only resample, we only took they have a much more complicated normalization process. We only took the resample out, but they also center all the things. They also all turn them in the right way. They put them in a bounding box so they kind of roughly all have the same size. So the original thing is a bit more complicated, but yeah, that's just as a side note. Okay, so let me show what the difference block reports. So for example, here I have a star that I just drew. I draw another one. And now I can compare this star. So let me compare my resampled current path with anything in here that is a star. So for example, let's do item 7. And again, no need for you to do that. You can follow along if you want. But then you have to figure out, you have to make sure that it actually fits. So here, this is the star I just drew. This is item 7, which is also a star. And now I'm comparing these two paths. Oh, what? Ah, wait. Item 7 isn't a path. I need to take item 1 of item 7 and then it should work. This is a path though. Yeah. Okay, and here I see that the difference between these two stars is 3,476. And I can now compare this to some other things. So for example, I'll compare this to the propeller, which is 10, and then hopefully get a larger number for the propeller. And for the propeller, we see I have a difference of 8,082. Let's try it with the heart, 3. Here I have 5,700, and then let's try another star. So let's do the 9, for example. That's 2,800, so this is even closer. So we see that the coordinates of similar things are closer together than the coordinates of different gestures, which is kind of on the nose, but pretty cool to see. Let's try it with one other thing. I draw a heart. So right now I've selected item 9, which is a star, and I'm comparing it to my heart. So this is 6,500. Now let me compare it to number 1, which was a heart 2. So this is just 2065. And then let's try item 2, which is another heart, 3,500. So they're both smaller than the star. So this is most likely a heart. And we already prepared a block for you that evaluates that and then gives the most likely outcome. And this block is called recognize, and this is the one that you can actually grab now. I'll open it really quick to explain to you what it does. The recognize block takes two inputs. One of them is a path, a resampled path to 64 points, and the other one is a list of patterns, which is with labels, which is our examples list. So in the first one, we put the path resampled by 64 points, and the second one will just put the examples. What the block does then, it has three variables: the difference, the minimum, and the variable that we think is the match. First, we initialize the minimum as infinity, a very large number, because we definitely want to find one that is closer than infinity. And this means as soon as we're having one example in our examples list, we're finding something that's smaller than infinity, so we just think it's that. And then we go through all the examples that we have in our examples list. And for every example, we do what I just showed you. We calculate the difference between the resampled path and that example that we're currently looking at. And if that difference is smaller than the current minimum, and you remember the first time the minimum was indefinite, like in infinity, so we'll definitely find something smaller. Then we set the match to the example that we're just looking at, and the new minimum is the difference that they had. And then we're going to the next example. And if the difference isn't smaller than the last one, we'll just omit it right away. And if the difference is smaller than the current minimum, then we'll say this one is the new match now. And the new minimum is what you had as a difference with the current path. And finally, once we've done that with all examples, we just report the word, the second item of the match, which is the label. So it's just the word that we wrote here. And this is how the recognize block works. So if I try this now, I'll resample my current path to 64 points and try to find that in the examples. And if I click on it now, I hopefully get the word heart, which I'm getting. I can try this with star. This is a star. I can try this with propeller. It's a propeller. And I can try this with the clef. And it says clef. So this seems to work for all my examples. Maybe try this. So you build the structure and then you draw different examples and you try it. Uh-huh. Okay. Okay. While you're experimenting, I'll quickly look for the video, keep working on it, just try whether it works with all your examples and also draw them a couple of times and make sure Okie dokie, I found it. So, for those people who were interested in a recording, I hope there's one provided, but if not, oh God, now I lost the chat. Here's a video where we very lengthily explain this to university professors who can use this as a resource to teach different things. And I opened the video here. You can see it's crazy long. It's 2 hours, like 3 hours roughly. But there's a talk in the middle of Mark Gastiles, a pretty cool computer science education professor. So if you feel if you're interested in that, feel free to tune in. Just for everybody who wants to follow up on this. Okay. So I hope for your examples, the recognizing process worked. What I wanted to show you is here I drew a heart. I clearly drew a heart, but this one says clef. What we found out is let me try it again. This one now thinks it's a propeller. Let's try this again. Propeller. What we found out, Jens, my colleague, and I, when we did this the first time, he was giving me his project, and none of the gestures worked. None of them. And then at some point we figured out that it's quite interesting. Jens is right-handed and I'm actually left-handed. And apparently left and right-handed people draw things different ways. Like I draw everything I do starting from left to right usually. Like all the hearts that I draw this way. The stars work differently. All the stars I start like this. But there's different ways to draw things. Like I could draw the same thing like that. But now when you think of it, we're comparing coordinates. So the first version I did, I moved from here to there. The next version I did, I moved from here to there. So those are very different. It looks the same, but they're very different gestures because we're not actually comparing images, we're comparing paths that people have been drawing. So it is important, and this is also a nice way to talk about bias in when working with AI, because usually the problem is that you don't have good training data. And in this case, for example, I only trained this thing for me. If I want a wide variety of people to be able to use this, I probably should have provided different examples. So I probably should have drawn a couple of hearts this way too and added them to my list. This also makes it more complicated than though to distinguish different things. Because if I just have this one way to draw the heart, everything that roughly looks like this is a heart, or kind of close to this. If I have different ways, I might get interferences with other things that are closer together. So it's a trade-off if you want to have your thing for like available for everyone in this case and then have a wide variety of examples to train it on, or whether you just want it to work for you but then it works 100% because you draw it always the same. Or for example, for the propeller, I started it always at the bottom, but I could have also started at the left arm or at the top arm or at the right arm, and those are all different gestures. So keep that in mind if you share stuff with other people, that you also accommodate their needs or the way they could draw things, because otherwise it might not work for them, which happens very often with AI programs that they kind of forget people. So I don't know, Mercedes once had this problem that their voice recognition system didn't really work. It worked way worse for women, for example, because when they trained it, they did it with all the men working at Mercedes who had rather low-pitched voices. So it was really bad at recognizing women's voices who spoke with a very high pitch. And there was a problem in the training data because they just didn't represent everyone while they trained their probably neural network to recognize the speech. And there's a couple of other examples. So this is a pretty cool way to illustrate that. If you only train it for yourself, it might not work for other people you want to share it with. Okay, and now there's one last step that we need to do, because now we can recognize things. This is a heart now and this works now, but now I want to actually trigger these animations I had with the stuff I recognized. And let me actually rearrange this here so I can add one or two last things. automatically want to recognize something once I'm done drawing. And I can do this by just, I want to recognize it and then I want to trigger the reaction. And I can do this using the same broadcasting receiving idea that we used before, but I can just broadcast whatever I'm recognizing here. Because this is like what I'm getting back here is a word. So I can just drop this in here and broadcast the word. And now I can add when I receive blocks to all of this. So when I receive this heart word, you just need to make sure that you spell everything the same way you did it in the examples, because this is the word you're going to get. So now let me actually try drawing a heart. And now it recognized this and it automatically triggered the reaction. Now when I draw a star, it does recognize the star, but I didn't add it here yet, so it doesn't do anything. So let's add the star thing here. When I receive the word star, I now want to trigger the star reaction. That worked too. Okay, when I want to draw the clef, now let me actually take this out again. I wanted to trigger the clef reaction. Did that work? Yep. So here, when I receive clef, and again, this works like we did it before. You just click on the drop-down menu here and select new, and then you can type in any message you want. So that works. And then the last one was a propeller. Let me try the clef first again. So this seems to work. Okay, maybe I'll reduce the number here, otherwise it'll be done for, like, it will never be done. And then the last one was the propeller. So let me draw a propeller again. Did it work? Yep, this one recognizes two. So let me add the when I receive thing here. Ooh, when I receive the word. You can also just click on the scripts that triggers them too. When I receive the word propeller, I want to trigger this. So let me try it again with the propeller. Okay, this works too. So now I built a couple of examples that don't really fit well together, but we could like tell a story like, for example, although it's a very bright night outside here and it's actually pretty cold and I can see the stars, I'm rather staying inside doing this workshop with you because my heart just beats for computer science. Additionally, all my flatmates are just making music outside. Some of them are singing, some of them are playing the pianos downstairs. And once the workshop's done, I'm going to rush down and try to sing a song with them. So you can use this to actually animate um stories, and this is a nice way. Like if you'd be teachers, I do this a lot with teachers. If you'd be teachers, I tell you pick a children's book and give everybody like 2 pages of it in a workshop, and then let them come up with animations for that, or have a whole fairy tale like we did it with the like I did it at the beginning with the Snow White fairy tale. But pick a traditional fairy tale from the country you're from and try to come up with a couple of nice animations while you while you animate the fairy tale while you tell the story. That probably also works with your brothers, sisters, kids, grandparents, whoever you want to tell the story. And it's kind of fun. I like it. I like that it's actually your own drawings that you're animating. And then maybe like 1 or 2 more tricks. You can, as I said before, you can also record sounds. So for example, for the clef, I could have recorded a sound. And this is my sound. Okay, wait, let me actually share the sound so you can hear what I'm doing. So I just recorded this thing that probably you heard. And I could play the sound whenever I'm starting the animation here. So now when I'm drawing the cliff, I can also I can also play this sound. So this is something that you could do. What also works super well, and now let me actually open another project. Last time I presented this, I did the caterpillar, the how is the name? Like the caterpillar that like grows up to become the Eric Carle book, that eats through all the thousands of foods and then becomes the butterfly. How long? That was here. And what also works, because here I drew a couple of butterflies, and that's a really nice animation. In here, I just have a couple of costumes for butterflies, and I made these. I just drew them in the paint editor here. But if I draw the butterfly costume, or the butterfly thing, and oh wait, no, this is no, this is not an egg. Go away. No, no. I need to remember how I did the butterfly. Probably something like this. No, this is also an egg. Oh my God. How did I do it? God. Anyway, let me just add it here. This is a butterfly. And let me do it like this again. This is also very nice about the algorithm. Is if it doesn't recognize your thing that you've just drawn, you can just add another one and say this is what I did before. And the nice thing here is like this is my butterfly, and I'm now using the other ones that I've drawn, and it's not actually using my animation. It's just it looks like it's using my animation because you can't really see the difference from what I've drawn and the things that are already prepared. So you can prepare other costumes to create more complex animations. That's kind of nice. Um, you can play with the size. So for example, if you wanted to do birds or something like that, you can draw a bird and you can set the size based on the positions where it's at. So for example, that the larger, like if the Y position is very large, you make it smaller. So it looks that everything that's up here at the top is farther away than when it comes down here, then it's increasing the size. So there's a couple of nice ideas that you can explore. But let me save my project again and share the link with you one last time. Again, also, if you want to add, like if you want to work with my examples, but just want to add yours to the list, you can just leave it the way it is and draw something new the way you're drawing it. So, for example, you're drawing the star this way, then you're just adding this as a star. Click here again, and now you have my examples and you have your examples too. And then if you do it that way, it should work with yours as well. So let me save it one last time, now for real. And I'll share the link one last time. And then, oh God, now I lost the chat again. There we go. And then you're good to go to try my project. And I think that's everything I wanted to share with you. Feel free to try out the resources, feel free to play with the project. I hope you had fun. I had fun, and I'm looking forward now really to the next year's festival. Okay, thanks everyone.
Hello, everyone. So I'm going to share with you right now the challenge code so you can confirm your participation. And while I share that on my screen, I will see this opportunity to say thank you very much. Yeah, this is a wonderful tool to really level up storytelling and have a lot of fun. I mean, you say that you do that a lot with teachers. We also work with children, and we love doing this kind of crafty things.
Feel free to
So
use it.
thank you so much for this. Um, and yes, we'd be very happy to have you again next year.
Thank you. I'll see you next year, hopefully. Bye.
All right, so
Bye,
here's the code. We're gonna
everyone.
leave it on for 5 more seconds so you can all write it down, and then we'll say goodbye. Bye, everyone.